Hey everybody, welcome back. So today we're going to be working in RNBO. We're going to take this patch that I have here on the left hand side and basically re-implement it in RNBO, which I think is a pretty common thing. It's definitely what I found myself doing when I started using RNBO, is taking all my Max patches that I already had and just building them in RNBO so that I have the power then to export those patches and use them in lots of other places, like on the web, in a plugin, or as a Max external. And that in particular is one that I've been doing quite a bit because it makes the patches easier to share. It also makes them run a little bit more efficiently on the computer, and it allows them to support MC, so you can actually have your patches be multi-channel enabled pretty easily. So we'll go through the process basically of taking this patch I have here on the left and just re-implementing it or porting it over to RNBO. And then the result that we're going to eventually get to is an external, which I actually have already created and have down here in the lower right hand corner in orange. So let's start with the patch. So it's pretty simple. Really the only user interface is this matrix control that creates a little gate pattern. And then I have a phaser, which is going into a subdiv object. And the number of subdivisions is equal to the length of the pattern. Those subdivisions are then getting turned into regular pulses by the what tilde object. And those pulses are also being used to look up the values of each of these steps in the pattern, which has been fed into the stash object. So effectively then that's triggering either a 1 or a 0, which is opening and closing this gate and choosing which impulses to let on to the synth, which is implemented in Gen, and which I borrowed from the Go book that I talked about in the prior video by Graham Wakefield and Gregory Taylor. So that's what I have there. Over here, this orange object is the external, which does the exact same thing. So it's exactly the same function. It's just that this is a Max object. If I double click this, nothing happens, whereas this is just a normal Max patch. So let's move on with actually implementing this thing in RNBO. So I'm going to get rid of a few things here. One thing that we're going to keep is the matrix control as our user interface. And I have already created the RNBO patch here, and I have it open here on as a tab here. Okay. So what I'm going to do to start is just copy a bunch of the patch, everything except the UI part and the kind of output part with the live.gain and the EasyDAC. And I'm going to paste. And you can see that we're part of the way there first, at least. Definitely want to get rid of the RNBO patch itself. I don't want a patch inside of itself. And also this we need to get rid of. And now we need to kind of work through the process of supporting some of these brown objects that RNBO doesn't support. Any of the ones that are blue, it totally worked. Basically, there's an analog in RNBO to the Max object, and Max is smart enough to realize that that's what we're doing, and it just creates that object for us, which is pretty convenient. So we'll start off with outer UI, and actually I'm going to create the alternative by going through the same process that you might use to create an outer UI. So just click that little yellow icon on the left side of the object, go to the attributes menu, select the attribute. And then ultimately what we're going to want is for somebody to be able to send a message or use an outer UI in the RNBO patcher, right? Something like this over here that's connected to the RNBO patch to be able to control that tempo. And the way that we're going to do this is create a param object. So I'm going to create a param object, call it tempo. I could call it BPM or something else if I wanted to. The default's going to be 120. And I'm going to set a range, minimum of 0.1 and maximum of 1,000. And then I'm just going to connect that to this set object. So set is the way in RNBO basically that we can pass numbers into objects to control specific attributes of those objects. And the reason that this is necessary is because there are no symbols at all in RNBO. So you can't send a message box like you would normally in Max to the object to change the attribute value. You have to use this set object. I'm also going to create an inlet here in place of the toggle because we don't, while you can use user interface objects inside of Rainbow, and it can be useful while you're patching, ultimately you're going to want to move away from them because once you export things, no one's going to be able to get into the patch, right? So in this particular case, I'm just going to create an inlet, and then I'm going to create a toggle and connect it here. In place of live.scope, I'm just going to create a regular scope tilde. And I'm just going to paste replace these. And this one too. Great. Zeal.len doesn't exist in Rainbow, but list.len does, which is basically the exact same thing. And that's going to get the length of the pattern that we send in, the list of zeros and ones that we send in. And eventually that's going to go into a patch that we make that emulates subdiv, because subdiv and these other 8.3 objects don't exist in Rainbow. So I'm going to create a subpatcher here, and I'm going to just call it subdiv. And I'll create an inlet, in one. And you notice here that when I create the inlets and the outlets, if I expect there to be a signal passed in there, I'm going to use a tilde, which means that that inlet will only accept signals. And if I don't use one, then it will accept events. So I have two inlets, one for signals, which is going to be for the phasor, and then I have another one for the pattern length. And then the output is going to be my subdivided phasors. And we'll build that patch in just a second here. Okay, so next we'll create an abstraction, or sorry, a subpatcher rather, that replaces the what tilde object. And that's going to take in the phasors from the subdiv, and then we're going to have an outlet that is going to output impulses, because what's going to basically just convert phasors into impulses. And then finally stash. Great. So now if we connect things up, we're going to connect the phasor to the subdiv to the what to the stash. I forgot to make the inlets in there. In one, out, one. And it looks like I have some error. What is it? Error compiling generated source. Why? No, I don't believe that there's an issue here. Okay. I don't know what happened there, but it's fine. So we're going to connect this list.len into the subdiv, because basically we're going to be subdividing, creating that many subdivisions of the input phasor. And when we go in there, I'm going to scale the phasor that comes in by that number. So a ramp from 0 to 1 becomes a ramp from 0 to 8. And then we'll just use a wrap object to wrap every segment between two whole numbers into a ramp between 0 and 1. Oops. So now if I come back over here and I hit that toggle, you can see we actually started the transport in the main max match and the one in Rainbow, because they're both linked to the same transport. So one thing I can do to correct that is just come in here into the attributes, select transport, and give the transport that's sitting inside of Rainbow a different name. And then while I'm here, I can also create an adder UI for the tempo. which is exposed to us because we used param here. Great. So if I run this again, you can now see that we are getting a phaser. If I now send a pattern in, it will take the length of that pattern, although I have to make sure that I'm actually sending it into the object, which I am not. Okay, there we go. And I need to send it again. There we go. So we have that list coming into this second inlet, we're getting its length, and then we're using that to create subdivisions. From there, we're going to create a very simple copy of the what object, which you've probably seen in the past on this channel. We'll take the delta, which is basically the slope of the line. It's the difference between the current sample and the prior one. And then we'll ask it to tell us when that value dips below 0. Give us a 1. If it's not below 0, give us a 0. And the result of that is going to be that every time the phaser wraps around, and I have to re-trigger the transport here, that we get an impulse. One thing you also might have noticed is that as I'm adding and removing and changing the patching here inside Rainbow, we're getting some messages down here that say things like generating or compiling, and there's kind of a blue bar that moves across here. That's the process of the Rainbow patch compiling. So anytime you make a change, in order for those changes to actually take effect and influence the function of the patch, this compilation process has to happen. And by default, it happens automatically anytime you make a change. If you want to disable that, which sometimes makes sense when you're working on bigger patches, you can do that by clicking this circle down here. Cool. So we have our impulses, we have our phaser, and we want those impulses actually to go into the right inlet of the gate here as well. And so now we have to think about the stash component. And this is where we're going to deviate a little bit more from how things look in Max. And it's helpful to take a step back here and kind of think about how stash works. In a way, stash is kind of like a 3-part object that does 3 things. The first one is it's a container for numbers, basically. I can send a list of numbers into the stash object and it's going to store them for me. The second is the writing, so the actual taking of that list and putting it into the container. And then the third is the reading. So when I send something into this third inlet, depending on the mode, in this case I'm in the default mode, it will report back those numbers. In this default mode, if I just send an impulse into the third inlet, it's going to just give me the next value in the list, and it's just going to step along one after the other. So what we're going to do in Rainbow is basically create 3 different objects that do each of those 3 separate functions. So the first one, which is the container, is called data, which is an alias of the buffer object with a few different characteristics that make it useful for what specifically we're doing here today, but you can think of it as being very similar to a buffer. We're going to give it a name, which is pattern, and then we're going to give it a length, which is in samples, which is 64. So basically what this means is we can store 64 numbers inside of this data object. Then we're going to create a poke object. We're also going to refer it to that pattern container, and poke is going to be responsible for the writing. And then finally, we're going to create a peak tilde object, which is going to be responsible for the reading, and we're going to put that over here by the stash. Great. So if I connect a print object to the second inlet of the Rainbow patch here, and I go back to Max and I just send some pattern through, I have to wait for the compiling to happen before I can actually do that. There we go. Then you can see that it's being printed to the console. So we're just getting that list into the Rainbow patch. And what we want to do is basically just put this into the data object so that it can be read back by the peak object. And the poke is what allows us to do that. It has 4 inlets. The first 2 are the ones that we care about. The first one takes the value that should be written into the buffer or into the data object. And the second one is the position, basically the slot at which we are going to do that. So because we have an 8-step pattern, we're going to be storing numbers into slots 0 through 7. So in order to accomplish this, the first thing that we'll do is take that list and pass it into a list funnel. which is going to take this 8-item list and break it up into 8 2-item lists that look like this, where the first item is position and the second item is the value. Now, the poke object, the first inlet is for the value, which is the hot one, and the second inlet is for the position. So it wants to receive that position first, because if I send the value first, it's not going to know where to put it, and it's probably going to put it in the wrong place. So instead of just straight up unpacking this right away, what I'm actually going to do first is reverse it. So I'm going to use list.rev to flip that list around so that the value comes first and the position comes second, and then that allows us to unpack this correctly. Because in Rainbow, just like in Max, there's that right to left ordering, right, where those values towards the end of the list are going to come out first. And one other thing that we might want to do just for housekeeping purposes is make sure that that list isn't longer than 64 items, because the remaining items will be useless to us. And then also, not a bad idea would be to just make sure that the values are either 0 or 1, and we can do that by using this bool object, which converts non-zero values into 1 and leaves 0 values as 0. So this isn't a bang like it might be in Max. It's actually a Boolean converter. Okay, so now if I go back to Max, I send something in here. We're basically just storing this list into the pattern container. And now we just need to read that back. We'll do that with peek, and its left inlet will take an index. So pretty much the same thing that's coming into that cold second inlet of poke, a number that indicates a sample position. So rather than sending an impulse from the what object, what we're going to do instead is get the position from the subdiv, which will take from the point where we have completed the scaling, but we haven't yet done the wrapping. So I'm just going to take that, connect that into peek, and then connect that straight into the gate, and we can actually get rid of this stash abstraction. And then you can see here we're actually already getting some sound. So if I come over here and I just make this scope bipolar, you can see we're getting waveforms that look like sound. If I create an outlet, and then I go back into the main Max patch, and connect things here, and restart this, you can see that it's now working. So this rainbow patch is doing exactly what our Max patch did. And now our final step is simply to export it. So I'm going to get rid of the scopes because we don't really need them anymore. I'll clean things up here just a little bit. And now we'll proceed with the exporting. So the way that we do that is we go over here to the right-hand side. There's this menu. The bottom icon is the export options. You can see there's many places that we can export, C++, JavaScript, all these others. I'm going to choose the Max external. The output directory is where that external is going to go on my computer. The default location is good for me. Next is the operating system. You can export for any operating system. So if I'm in Mac, I can make Windows externals, no problem. And the same as the other way around. I'm just going to make a Mac one for now because I'm on a Mac. I'm going to give the externals name. I'm going to give my name. How about a description, whatever that is, tags, and the transport attribute. So this is where we say whether or not we want this transport attribute to be available to the external, which we definitely do because we're using a transport object inside of this patch. And then this next option is where we decide whether or not this thing will be MC enabled. And in many cases, we could probably do a video about that in the future. It's really as simple as clicking this button, and then you have this cool MC patch. it only makes sense in certain situations where you're doing audio processing, but it's pretty amazing. And I've made a bunch of things where, I have an abstraction, it's cool, I really wish it could do MC, and so all I have to do is build it in Rainbow and then export it as an MC enabled external, and it just works. So it's pretty awesome. These polyphony settings have really more to do with the scenario where you're building a synth that accepts messages like MIDI or node on and node off events of some other kind. And you have to do kind of voice management in that type of situation. So they don't apply to us here. And finally, open export directory. This is just where we say whether when it's done exporting, it should open the file for us in the file browser. So with all those selections made, I'm going to click this button in the lower right hand corner, and it's going to start the process of making an external. And the way that this happens is I'm connected to the internet. It's sending the Rainbow patch to a server somewhere in the cloud that is actually going to build this external for us. So this isn't happening on my computer. Now all my computer is doing is waiting to get back this external that's been fully built for us. Great, so that's done. It's asking me if I want to restart because I actually already made this external in the past, and it would need to restart to reflect to see the new one that I made, but I'm going to ignore that for now. And you can see here that it's actually opened this folder called Rainbow Generated within the packages folder, which is the default place where these externals exist. And you can see that here it is, rhythmplayback.tilde.mxo. If I come back over into Max, I can create this, and you can see it's an O, which means it's an object. And it actually even creates help documentation for you. It won't say very much. We have our attributes that we defined. And so you can update this and make it look nice, and you can also create a help patch and do all the things that real Max patches have. And if I connect now my controls, so I connect the attributes, I send the pattern, and I connect as well the audio cables, and I give it its own transport, and I send the pattern, and I start it. There it is. It's doing the exact same thing. Oh, it stopped the transport when I moved that. There we go again. So that's it. That's how you make an external in Rainbow and Max MSP. Let me know if you have any questions down below. I love to see those. I love to see suggestions and questions and ideas. If you're enjoying these videos, please hit the like button and subscribe. And I will see you next time.